An aurora is a natural light display that shimmers in the sky. Blue, red, yellow, green, and orange lights shift gently and change shape like softly blowing curtains. Auroras are only visible at night and usually only appear in lower polar regions. The aurora can be seen near the poles of both the northern and southern hemisphere. In the north, the display is known as the aurora borealis. In the south, it is called the aurora australis. Auroras are visible almost every night near the Arctic and Antarctic circles, which are about 66.5 degrees north and south of the equator. In the north, the display is called aurora borealis, or northern lights. In the south, it is called aurora australis, or southern lights. These northern and southern lights have fascinated, frightened, and inspired humans for centuries. Auroras and the solar wind. The activity that creates auroras begins on the sun. The sun is a ball of superhot gases made of electrically charged particles called ions. The ions, which continuously stream from the sun's surface, are called the solar wind. As solar wind approaches Earth, it meets Earth's magnetic field. Without this magnetic field protecting the planet, the solar wind would blow away Earth's fragile atmosphere, preventing all life. Most of the solar wind is blocked by the magnetosphere, and the ions, forced around the planet, continue to travel farther into the solar system. Although most of the solar wind is blocked by the magnetosphere, some of the ions become briefly trapped in ring-shaped holding areas around the planet. These areas, in a region of the atmosphere called the ionosphere, are centered around Earth's geomagnetic poles. The geomagnetic poles mark the tilted axis of Earth's magnetic field. They lie about 1,300 kilometers, 800 miles, from the geographic poles, but are slowly moving. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from Earth's atmosphere. The energy released during these collisions causes a colorful glowing halo around the poles, an aurora. Most auroras happen about 97 to 1,000 kilometers, 60 to 620 miles, above Earth's surface. The most active auroras happen when the solar wind is the strongest. The solar wind is usually fairly constant, but solar weather, the heating and cooling of different parts of the sun, can change daily. Solar weather is often measured in sunspots. Sunspots are the coldest part of the sun and appear as dark blobs on its white-hot surface. Solar flares and coronal mass ejections are associated with sunspots. Solar flares and coronal mass ejections are sudden, extra bursts of energy in the solar wind. Sunspot activity is tracked over an 11-year cycle. Bright, consistent auroras are most visible during the height of sunspot activity. Some increased activity in the solar wind happens during every equinox. These regular fluctuations are known as magnetic storms. Magnetic storms can lead to auroras being seen in the mid-latitudes during the time around the spring and autumnal equinoxes. Auroras have been visible as far south as the Yucatan Peninsula in Mexico. Magnetic storms and active auroras can sometimes interfere with communications. They can disrupt radio and radar signals. Intense magnetic storms can even disable communication satellites. Coloring an aurora. The colors of the aurora vary, depending on altitude and the kind of atoms involved. If ions strike oxygen atoms high in the atmosphere, the interaction produces a red glow. This is an unusual aurora. The most familiar display, a green-yellow hue, occurs as ions strike oxygen at lower altitudes. Reddish and bluish light that often appears in the lower fringes of auroras is produced by ions striking atoms of nitrogen. Ions striking hydrogen and helium atoms can produce blue and purple auroras, although our eyes can rarely detect this part of the electromagnetic spectrum.